graph transformations, which are probably on the slightly harder end of the transformations part of the course. So we're starting off with a sketch of y equals f of x plus 2. So I'm sure you've already learned how these transformations work, but just give a think about what this plus 2 entails. Does that mean a shift horizontally, a shift vertically, positive 2, negative 2, or in which direction does it even mean? Is it even a shift at all? If you remember it to be a shift upwards, you'd be correct. To kind of get an understanding for it, f of x basically just spits out a number, let's say like 5, and you just add 2 to it. So and that contributes to the y portion. So all it does is it just bolsters the y by whatever number is in front of it. So obviously they've given us f of x, all we need to really do is just shift everything to up. So this point is at here, so we just shift it up by 2. This point is at negative 2, and just shift up to the 0 point. This is at 0, 0, bring it up to 2, and so on. So I think from here we can kind of get a decent sketching ability. Obviously it's not going to be a perfect sketch, but kind of get the idea. It's basically the same thing, except just shift it up by 2. So here we have a negative. So now you have to kind of think to yourself, what does this mean? Does this mean it's flipped? Does it mean it's moved again? And if it's flipped, then where is it flipped? So give that a think. You pretty much just have two options. You have a flip in the y-axis and you have a flip in the x-axis. So this would be a flip in the y-axis. You'd take each point, sorry, a flip in the x-axis. So you take the points to the x-axis and just carry them on. You take the point to the x-axis and carry them on. So this one would stay there, and this one, say pretty much going 3 there, so 3 down. And you pretty much just sketch this. Oh. Sorry. So it's a hard sketch, as you can see. You basically go up to the origin, and then down, and that would basically continue. That's kind of it flipped in this axis. Alternatively, you could also have it flipped in the other axis, in this, the y-axis. So here again, you'd go and just kind of think about the points. So this point to away starts here. This point is on the origin, so it stays. This point is 5 away, so it basically be 5 away over here. And this point is 3 away, so it should be 3 away over here. So yeah, you can just imagine how this sketch would kind of go. This goes to that side, over here, and then it kind of shoots off. That's basically your sketch in the x-axis. So which of these do you think looks more correct? If you thought it was the sketch in the x-axis, you'd be correct. To kind of get an idea of why sort of something along these lines, is more correct, is because it is correct, is because of what happened. Again, f of x spits out a number, so for example 5, and you're making that negative, and that is all happening to the y-axis. So you take a number, you just make it negative. That's what's happening to the y portion. So if a number's here, you just flip it negative, and that's all happening in the y-axis. So that's pretty much why that's what happens. I want you to think similarly to the previous one, but now introduces 2 new transformations, as well as wants you to think about what happens to the points. So of the minimum point, so you're working with a point 3, 1, and you want to think about how this point changes. So obviously we've already covered that adding 3, all you really do is you just add that number to the y portion. So there's obviously just 3 and 3 plus, sorry, and then 1 plus 3, which is just the same as 3, 4. That's why this would just be 3, 4. Well, you're just shifting it up. So f of x minus 2. So if you've done this, what this really means, I'll give a quick think about what you think it means, is a shift instead of the y-axis, up and down, is instead a shift in the x-axis, so sideways. And unintuitively, not minus 2, but actually in the opposite direction. So if it's minus 2, you'd move it forward by 2, and so on. And this is pretty much just something you have to learn. Obviously, if you want an understanding for it, you can probably have a look around. So this one's a little bit harder to explain, but I guess just know that it's a shift in the, so make this negative, and that's how much you move it along the y-axis, sorry, the x-axis. So obviously the y-axis would stay the same, so the 1 stays the same, but this 3 would move by 2, so it would just be 5 in the positive direction. And here we have multiplicative 1, so of half x. So f of a half x really just means that, so if it was a half f of x, then everything would be half the distance that it usually is in terms of the y-axis. So this would be like that. But here what's really happening is it's changing the proximity to the y-axis itself. So in this case there are the distance is 3 between the y-axis and this point, as in like some 0 to that point. So you'd basically half that. Well, as in like the scale factor halves it, but you'd actually be doing the opposite. So if it tells you to do a half, you just do 1 over that, which in this case is just 2. So actually, it needs to be twice as far as it usually is. So in this case, it would go up to 6. So it's usually 3, but instead it would double all the way up to 6. But obviously, the y-axis would stay the same. That's pretty much something you just have to know. Focuses on consolidating the graph transformations you've done, and also has a question on combining them. So I guess we'll just get started. So you start off with the point 3 minus 4. That's what they're looking for. You to translate, transform, whatever. So in this case, you have f of x minus 2. So kind of thinking about the transformations you could have with minus 2, I guess there are quite a few options. You could, I guess, something 5 minus 4, maybe 1 minus 4, maybe 3 minus 6, 3 minus 2. There's quite a few possibilities. Which of these seems to make the most sense? Or which of these do you know is the answer? Give it a little think. Now, when you're dealing with a question where the change is actually inside the f, so instead of being f of x minus 2 outside, is instead inside the actual f, then you basically take that number, in this case minus 2, and multiply by minus 1. That's always a rule. And you get 2. If you had 2, obviously when you multiply by minus 1, you get minus 2. And that basically shows you how you should move it along the x-axis. So 2 basically just means, obviously, you just shift it 2 in the positive x direction, which would mean just increasing this number by 2, because that's the x coordinate. But this doesn't really change. So yeah, you would be left with 5 minus 4. That's what you thought, and well done. And this one basically focuses on combining transformations. So combining transformations in this specific regard isn't actually that difficult because they're both independent. Obviously, this one focuses on the y coordinate and this one focuses on the x coordinate. But I guess if you think about them individually, what would you get? So with a plus 6 change, this is pretty simple. Literally just whatever's on the tin, the plus 6, just apply that to the number. The minus 4, you'd add 6 to it, you'd be left with 3, 2. However, you also have to not forget that there is an x transformation here as well, which is the plus 5. So again, 5 times minus 1 gives you minus 5, which means a transformation in the minus x direction. So you'd be taking away 5 from this, which would just leave you with minus 2, 2. Here's the last question, which is an extension. It's meant to be quite difficult, and it might be harder than pretty much any question in GCSE, but if you're an aspiring 9th student and would like to push yourself and understand a little bit more about the topic, this could be a good question to attempt. So firstly, we'll start off with kind of getting an idea. So the first question, give a full description of each of these Schur transformations. So you have, obviously, you can see the similarities, and you can see maybe where you can start devising a transformation in each of these. So I think first would be easiest to think about this inside the x transformation. You have a plus 2, so f of x equal to x squared. So what might be useful is to kind of use the f of x notation, if that would help you. You kind of think of it as g of x is equal to 3 f of, in this case, yeah, x plus 2. So what that would mean is x plus 2 squared. So yeah, f of x basically means take whatever's in the brackets, in this case x, and then square it. In this case, you'd be taking x plus 2, squaring it, and multiplying it by 3. So the first transformation I guess you could think of inside the bracket is obviously this transformation. So we've already kind of covered this in the previous questions. Basically what it is just a translation. Maybe you could just use a vector notation here of minus 2, 0. So again, we take this plus 2, multiply it by minus 1, which gives minus 2, and that would basically be the amount we move it in the x-axis. In this case, they're looking for the actual translation, which is minus 2, 0. So now we have to think about this part, the 3. So this wasn't really covered in the previous questions. But if you kind of think about what's going on, you might be able to get an idea. So what does this 3 mean exactly? Does it mean taking whatever the x coordinate is and just multiplying it by 3? To be dividing by 3? Is it maybe the y coordinates being multiplied by 3? Or so on? What do you think it is? Thinking about what's actually happening here. So just to kind of give you another nudge in the right direction, you can reframe f of x as y equals. In this case, what's happening is y equals 3. So I guess it's kind of summed up here. Y equals 3, x plus 2 squared. So this x plus 2 squared, you can kind of imagine as one, it spits out a certain number. And then we're multiplying that number by 3. So think about what that actually does to the y. So if you kind of guess that whatever the number is, whatever the y coordinate is, we just multiply it by 3, you would be correct. What this really means is, let's say y equals some number, and we're multiplying it by 3. So that y would just go, be multiplied by 3. So what this is pretty much is just, if you were to, I guess, to describe it, it would be, in terms of transformations, would be, you would just take whatever the y coordinate is and just multiply by 3, which I guess you could say is sort of an enlargement of that specific point about the x-axis. Because if you think about it, if you had an axis, let's imagine over here, we had a certain point that was here. Maybe the coordinate was, let's say 5, 1. So what we really be doing here is taking that 1 and moving it up to 5, 3, as we've already gathered. So it's pretty much just an enlargement by scale factor 3, or I guess, yeah, in this case, scale factor 3 about this point. About, which in this specific case would be 5, 0, but would be the axis in that case. We really have to describe it as a transformation, but that's kind of the general idea about what's happening here. Now part B. Graph of G is translated by this vector to give the graph of H. So I guess it's pretty useful to think about what this actually means and maybe try and incorporate it into this. So translated by vector minus 4, 5. So the minus 4 is the x-axis movement. So now we have to kind of work backwards. What does this minus 4 actually mean? If we were to, let's say, if we just had the original x squared, or I guess if you thought about it as f of x, if we were to do a minus 4, what would that go to? Would that go to f of x plus 4? Maybe f of x minus 4, f of x plus 4, or something else. Give that a little think. If you thought that it would be none of these, you'd be correct. No, I'm just kidding. If you thought it was this one, you would be correct. So the reason is that again, you take whatever transformation is here and you multiply it by minus 1, which in this case, 4 times minus 1, 4 times minus 1 just gives you minus 4, which is this transformation. So the actual movement would be minus 4. That's why x plus 4 is correct. So that's kind of what we're doing inside the bracket. But if you look at our actual equation, we already have a plus 2 in there. So what we're really doing is just adding a 4 to that. So if we ignore the 3 for now, or as in if we ignore anything else, all we really have is 3 f of x plus 6. So, and that's mostly it. But now we have to consider this, the 5 at the bottom. And the 5 is a change in the y direction. And I think in general this does make sense as to why all you have to really do is just tack on this number to the end. So all you really have is 3 f of x, sorry, 3 f of x plus 6, and then tack on a 5 there at the end. And obviously in the context of our specific example, this would just be 3 x plus 6 squared plus 5. And that's our final graph that we're working with here. And that's g. That now g is equal to that. So if we were to just summarize that, g of x is equal to this. So now the point 21 on the graph f, so now we're going back to f, is translated on the point P to the graph H and find P. So now I guess we can just think of 1. It's translated to the point P on the graph of H. So the graph of H, a lot is happening to the graph of H. And so this is the new g of x, but really they tell us in the question that this is the graph of H. So we can just say H is equal to this. Or I guess h of x, if that would help. So yeah, maybe we just write that, h of x. So this is that graph, and when we compare it to f of x, we basically just get x squared. So obviously what's happening here is where so the only way we can kind of think about first that this part corresponds to the x-axis and these two parts correspond to the y-axis. So maybe we could just think about the y-axis parts first. So we start off with plus 5. However, this plus 5 is kind of out away from this part. So you might think to add 5 first and then multiply it by 3, but really you'd be adding 5 right at the end after you deal with this block, because obviously this 3 is attached to this x bar, which is the first thing you'd be doing. So if you think about it, the -1 would go up to -3 through the 3 mechanism. You'd be adding 5 to it, which would just result in -2. So in just positive 2. So -3 plus 5 would just land you in 2. So the y coordinate is 2. So something x and 2. We just have to find the x coordinate. So the x is actually here plus 6. But what that really means again is just -6 movement in terms of the x. So this would just be 2 minus 6, which is equal to -4. So really what that leaves you with is -4, 2 as the coordinates of P. And hopefully that makes sense. That's obviously a decent amount harder than you probably need to use, but hopefully gives you an idea of where you can take and where you can go with this, and it gives you a little bit of